Okay, today's video is going to be about Rust and GraphQL, but let's do this video a little bit differently. I'm going to define the problem, that is the end goal that I'm trying to achieve, and then I'm going to start getting into the code. So the application that I'm building is called dchat, and it's a decentralized chatting application. Basically, all of the posts, all of the messages are generated as NFTs, and they're using both Solana and Arweave to store the NFT data. Blockchains are notoriously slow at querying, meaning getting back the data once the data has been inserted. So I'm creating a Rust-based backend server for caching purposes. And it's going to accelerate searches, keyword searches, username searches, stuff like that. Just make it a faster, better experience. Now, in order to do that, I need to query into Arweave, and the main query mechanism for Arweave is using GraphQL. So we're going to learn about how to integrate Rust with GraphQL, specifically in the way that Arweave is expecting. So in order to do that, we first needed to update the code on the client side that's actually inserting the posts as NFTs. So in the previous video, you guys have already seen this function right here that's uploading the NFT image and then uploading the NFT JSON file that points back to the image. And then, of course, this JSON's URL path is embedded into the Solana NFT. So that's how we were doing it before. So I, in this case, have wrong file. So in this case, I've updated or refactored that upload NFT file function, and it is in order to insert the Arweave tags. For those of you that are not familiar with Arweave, it's a blockchain for decentralized storage, but it can take any kind of data to be saved in it. But in order to be able to query that data at a later time, you need to associate certain metadata, certain tags with your inserted data, so that based upon those tags, you can query Arweave and then receive the appropriate data. So in the case of the tags that I need for dchat, there's always going to be a set of tags that will go in no matter what data I'm inserting into Arweave. So that's going to be the application name, which is dchat, the fact that the data is JSON specific content, the version number, the Unix timestamp, what type of data I'm inserting, etc., etc. So in addition to that, because if you recall, the content, the text content of the post itself is being inserted into the JSON file, I need to be able to query that. But again, the inserted JSON file is just pure data. It's either binary or base64 encoded string. So I can't directly query that. So what I'm doing is creating additional tags with the name keyword. And then those tags will have, specific keywords in them, based on like hashtags, @username, etc., etc. So those are being searched out, and then when the matches are found, then an individual tag is created in here. Again, Arweave tags, and then it's added in addition to the base tags that will always go in no matter what. So you have the base tags created whenever we upload an NFT file. So we got that, and then we say, Well, if this is a JSON file that I'm inserting, then there must be text content in here. So I'm going to parse that text content, look for keywords, and then I'm going to append them to the tags, and then I'm going to upload that into Bundler. And Bundler is the vehicle that makes inserting data into Arweave cheaper and faster. So if we run this, we see the collected keywords. So that would be from here. Obviously, these are just samples. And then this is eventually going to make it into Arweave itself. And if we take this transaction ID for this transaction, and this generally takes a couple of minutes to get refreshed on the server. So we'll just wait a little bit for that. All right, so it did come back. Took a couple of minutes, but here's my app name, the content type, the app version, the Unix timestamp in seconds, blah, blah, blah. Here's keyword 1, keyword 2, test user 1, test user 2. So now we know that the data is in there, but it's actually pretty complicated to interface with both GraphQL and Arweave. So I'm gonna, for the rest of the video, I'm gonna focus on that. All right, so the first thing you need to be aware of is that we're gonna use GraphQL client, because even though this is a server, it is acting as a client trying to make requests into Arweave. And that would be https://arweave.net/GraphQL. And then we're also going to use request, which is the HTTP client that's pretty popular on Rust. And yeah, so you're going to need those items. And then let's look over here at this main folder. So what's going on here is you need, sort of at a base level, you're going to need two main things. You're going to need the query itself. In my case, I have two distinct queries. This one has a query with a name, which is really just a label. And then it is taking an indeterminate number of transaction IDs. And that's the basis or the parameter of the query. So then after that is defined, we define what we want back, or the fields that we actually want back from the query. So I want the transaction ID, a cursor that I'm going to be using for paging purposes later, and then of course the tag values just to kind of double check and stuff. Pretty much the same thing for this query right here, except the parameters are a little bit more complicated. And then I'm going to show you, really I'm going to focus on this query because this one gave me a lot of problems. It's kind of, GraphQL client in general is pretty finicky because there's some code generation that is happening behind the scenes. So you have to have everything set up absolutely correctly or the code generation isn't going to happen. On top of that, there were some undocumented features in Arweave that gave me some problems. So we'll dive deep into that. So let's get rid of this terminal screen just so we can, yeah. All right, so then the other thing is you need to get from the GraphQL server, whichever one you're pointed to, the schema file. If you go to the documentation for GraphQL client, there's a really trivial little helper CLI utility, and in one line you can basically download this whole file. So once you have those two main features, what you want to do is you want to set up your actual real Rust code queries. Obviously, these queries right here aren't, directly being executed. They're indirectly being executed within Rust, so you need the Rust code that's going to trigger those. So the way this works is the first thing you do is you create a struct with the exact name of your query. So again, I'm going to focus on the more complicated query. The easier one is pretty trivial, so I don't think we need to go over that. But it has to be the same spelling, the same casing, no additional dashes or whatever in order to conform with Rust naming or anything like that. It has to be exactly the same. Once you do that, then you have to add a couple of attributes. The first one is going to be this trait. And if you're not familiar with Rust, these attributes get basically expanded into actual code. So this being a trait, if you were doing this manually, it would be something like, and then blah, blah, blah. But putting the attribute there is going to take care of that. Actually, is going to take care of that for you. And then this one is where, as I mentioned, we needed those query files and the schema file. So this is where you're going to be referencing those files. Make absolutely certain that the paths that you give are correct. This root represents wherever the cargo.toml file is. So that's where you're starting from. And then the rest of the path, in this case, to the JSON file, and then the GraphQL file over here. If you get this mistyped, then Rust Analyzer is going to tell you. But if you mistype this one or get the wrong path or whatever, oh, now it's working. Okay. Before it wasn't working. But sometimes when I was not having the right path here, Rust Analyzer for some reason was choking. But just make sure that both paths are correct, because as long as you have both paths correct, then you will be able to have the GraphQL client do some code gen for you. In other words, create Rust types that matches the edges, the cursor, the node, its subtypes, etc. On your behalf. Of course, you can type these out and create your own types, your own structs yourself, but why bother when this will code gen everything up for you? So that in reality is happening at compile time, but Rust is kind of helping you out by, reading through the code, just like how it knows that this is type variable by reading through the code. So it reads through the attributes and then gets that set up for you so that you can actually import them in and use them in the code. So that module, or in this case, we have two modules because we have two queries, but those modules are auto-generated and they're going to be within the module of this current file. So Arweave _GQL client is the module right here, right? Defined inside of main, because that's the jump off point for everything. So you can expect all of these types that you're going to need when you're getting back the data from the GraphQL server to be there. And then they're going to be there's going to be a sub module in there called the name of your query, but as underscore in between each kind of capitalized word, and then removal of the underscore. So in other words, snake casing. So in this case, get transactions by tags query is going to be get underscore transactions underscore by blah, blah, blah. I was using basically everything, so I asterisked it. In the case of this, I just picked out a few, but you can do, whichever one you want. So then once you do that, once you get that set up, you should get all the squigglies go away and everything should nicely type out. So in this case, I want to represent my get transactions by tags query as an actual Rust function, because that's going to be the thing that's actually triggering the query. So this thing is going to require a request client to do HTTP calls, because internally, when you're making these GraphQL calls, they're just JSON post calls anyway. So then after that, we need our environment variables. So I'm going to get that. And then for this particular query, we have two parameters, as you saw before. So we have these two parameters. One is just saying limit the amount of return data to X number. And then this is saying, hey, filter by these tags. So that's what I have here. And then let's get rid of this. And then our result is going to be, where is it? Oh, because, yeah, it's right over here. I was looking in here for some reason. But anyway, so it's going to be get transactions by task query transactions edges, which is representing this type right here. Obviously, Rust is statically typed. And then, of course, it just fails out with an error if nothing comes back or it blows up. So then what I need to do is I need to pass those mentioned variables into our query itself, right? So that's what I'm doing here. I'm going into our module, again, inside of the module that this file represents. So we're going inside of our module, we're getting the variables type, and then we're creating an instance of it, right? And then once we have that, we can pass it into the function that we want to run, and that function is get transactions by tags query. So this is the definition of the function that we're running. And then this call is just a little helper. It's a little utility for running, again, HTTP post calls from request, but in a shorter, less verbose syntax. So we just pass in the client that we happen to be connecting with, and then the path to our GraphQL server. Again, that would be Arweave, and then the parameters that we're going to be sending in, right? So then we get back that data. We await on it because it's asynchronous. The question mark means that it's going to blow up if something fails, but otherwise we should get back the data. And then what we do is we unwrap it. So I'm assuming if it didn't blow up, I'm assuming that it's good. So I'm going to unwrap it. I get the transactions out of it. And then I cast the type into get transactions by tags query transactions so that I can get IntelliSense and all of that good stuff. And then I return it as a vector of individual edge items. Okay, so that's the code for actually doing the physical, network calls into GraphQL Arweave to get the data in statically typed form. So then if we go back to our folder, our GQL folder, then we see this extra thing right here. So what am I doing here? So the reason why I'm creating a trait, which is a lot like an interface on the Rust side, so an interface in like TypeScript or C# or whatever, is because at the end of the day, I don't really care where I'm saving the data and where I have to query it, right? So if you look at this trait, there, other than kind of the root level stuff that I absolutely have to make any kind of query, my environment variables, the request stuff, the async trait stuff, stuff from the standard library. There isn't anything specific to Arweave in here, and that's deliberate. And then all these types, it's basically generics or associated types. But basically, I'm going to define what these are in my implementation. Oh, that's later. And I'll show you that in one quick second. But in my implementation, I'm going to define those. And then it's those things that are being either inputted in or outputted out. So, actually, I should fix these names. So if I ever have to change for whatever reason, or maybe my users want me to support other chains or whatever, and I'm going to have then I'm going to have multiple implementations of this trait. So what does that implementation look like? So yeah. So then this is the only implementation that I currently have, which is going to be Arweave specific. So we've got our GQL service and Arweave is implementing it. So as I mentioned before, we have Arweave specific implementation types for the parameter, for the tags output, and for the other type of output. For now, they're identical outputs, so I didn't bother creating a distinct set of structs for each one, but that might change over time as these queries become more sophisticated. But anyway, they'll do for now. So as you can see, the signature is the same as the trait by tags output, and then the tag param in here. So if we go through this code, we can see that there's a for loop in here, but the only reason why I wanted to do this is I was testing that this data is coming through properly. So, I'm going to get rid of all of that stuff later. So you can pretty much ignore this stuff right here. So let's go to the meat of it. So this call, I'll just highlight it, is this call right here in our client. So we have a client, sort of like how the HTTP request crate is a client to do HTTP requests. So I decided to create a client to do requests into our GraphQL server. And then the service itself is going to decide how that request gets passed data and gets, and returns data and blah, blah, blah. In this case, it's a very thin shell, but, obviously I can reformat this data or change the parameters at will by having an independent service. So anyway, so I make that call. We already reviewed the call. Let's assume it is successful. Then this converter will go from the code gen Arweave GraphQL specific types that GraphQL client created on our behalf. So that comes in as an input. It gets converted into ultimately the Arweave data type. And then that is what is ultimately being returned. As you can see here, because it's a vector of Arweave data. So that's that. And then if you remember this code right here from the earlier videos, so here we set up our Actix web server, and then in here we have our sub URL for GQL queries, and then this guy right here is going to represent the handler that is dealing with the requests that come in and then outputting the responses in JSON format. So I have a module specific to doing only that, meaning, separation of concerns. So you can kind of think of the stuff that is happening in these two files to be kind of one layer. And then this is another layer. So it's separating, it's acting as sort of a middleman between the Actix web server and then the query or service that is going to Arweave. So this middleman is doing all the route handling stuff. So let's get rid of this. So what it's doing is it's receiving those centrally stored relevant data. So the client, the config for the environment variables. And it's also passing in the, in this case, it's a post. So it's getting the JSON post parameters. So that looks like this. So it's that first limiter of how many records I want back. And then the JSON, the tag filtering. So that's up here. And all of these, of course, are deserializable because they're inputted as JSON. And then they get deserialized. So where am I? So then what I do is I create the proper type to be able to send into our function. Again, this guy. And again, our function doesn't know anything about routes. It shouldn't know anything about routes. So we're having the router take care of all of that. So the conversion happens here. We get the appropriate converted type to that is acceptable to our Arweave service. This is just an I64. And by the way, the I64 is part of the code gen. I would have made this a U16 just to save some space. But anyway, that's the way the code gen did it. And then a quick note. This had me going crazy. So the code gen by the GraphQL client is happening automatically, right? We already went over that. And it's based upon this schema file that we got from the Arweave server, right? Now, the tag filter type that was generated out from there, from that schema, is actually having 3 fields, not 2. Name, obviously, values, obviously, but then it has this operation field, which is, as far as I can tell, an undocumented field. I can't find it anywhere in the docs. So I was thinking that, well, I'll just go to default. So I was sending none, which was causing all of my queries that were taking tag filters as parameters to fail. But the responses, the failure responses, have nothing to do with this field at all. They're just some weird, JSON conversion errors. So it took me a long time to get this, but you want to be aware of this. If you're interested about, what the types are, it's equal, not equal, and then other. Other seems like custom, types. I'm still looking for documentation to figure out what exactly these others are. But I am using equal. In addition to that, be aware that, we're checking for a certain key, tag key, but we're sending in multiple possible values for that key, right? And when you make it, when you make these kind of queries, those checks are OR checks. So in other words, let's say my first value is, is keyword 1, and then my second value is keyword 2. If either of those is there, then it will send, then it will send the record over. So just be aware of that. So then that's it for the code. So if we go to our caller, and you can see here I have those expected parameters, and then you can see here I have the sub URLs. So then over here, if I query for, let me just blow this up. If I query for keyword 1, you're going to see I get multiple records. Right now, they all have the same tags: keyword 1, keyword 2, test user 1, test user 2, and you can see I get multiple records. But even if I do like, I'm still getting back the records because these are OR-based queries. So I just wanted to make that clear. All right, cool. So that was it. When you guys try and reproduce some of this code, be super careful about this stuff right here. Make sure all your paths are correct. Make sure the naming scheme is where is this thing? Yeah, that doesn't matter. The name of this doesn't have to be lowercase. I just wanted to keep it consistent. But make sure that the paths are correct, and make sure that your query in the file and the struct that represents your query is identical, or else you'll get like either weird silent errors that don't really tell you what's going on, or Rust Analyzer will just blow up, and then the AutoGen module will not create your CodeGen types, and you won't be able to use the statically typed form of the records. Okay, so that was it. The next video is going to be about SurrealDB. So initially, when I started this caching server, this acceleration server, I was going to use Redis. That's what everybody uses for caching and acceleration. But then I didn't like the syntax. It's got its own kind of weird syntax, and I kind of stumbled on SurrealDB. Real quick, SurrealDB is a database that allows you to run either in memory or on disk, and it is in the back end of it. It's actually a JSON document and graphing structured database like MongoDB, but on the surface, in terms of the developer interface, it's actually like 90% standard SQL. So I kind of felt like I was getting the best of both worlds. Currently, it's in beta, but by the time DChat releases, it'll probably be out of beta. It's getting a lot of attention on GitHub and stuff, so you guys should definitely check it out. All right, so that's it. Thanks, guys.